Okay guys, so we're going to start our review. Even though we're not going to have a test on this chapter, I want to make sure you guys get the information down, you feel comfortable with it, because it's still eligible to be on our final. So you see here, we're going to state whether a polygon is regular or not. Remember, for it to be regular, all the angles have to be congruent and all the sides have to be congruent. If you look at this first one, does it look like all the angles and all the sides are congruent? We see a really long side here, but over here you got kind of a short side. They're not going to be the same length, so no, this is not regular. Okay, our next one up though, look at this one. This looks almost perfect. All the sides are about the same. All the angles look about the same. So yes, we'd say this is regular. Down here, we know this shape as a square, or at least it looks pretty much like a square. So I feel like it's pretty safe to say this is regular. Squares have all right angles and all sides congruent. And then last but not least, I feel like this one could be tricky. You look and you see all the sides look to be right about the same. All of the angles seem to be pretty much the same. So I classified this one as regular. Our next one says state whether this is going to be convex or concave. Remember, for it to be concaved, it's caving in for most of them, but when you draw a line, it hits it more than 2 times. Convex only hits 2 times. So you want to choose a spot where it might hit more than once or more than twice. And we see right here, this hits 4 times. So it's concave. Concave. That's a terrible concave. But over here, let's try and see if we can draw. We see the spots where it pushes in a little bit seem like our best option. And once again, we can see where it hits more than twice. So it also has to be concave. On this one, let's see if we can come up with spots. You don't need to draw all these lines, but you're just going to try a couple out to see if there's any place. Since there's no place where it hits more than twice, we call this convex. And then the last one here, we want to see if there's any spot where this hits more than twice. And you see if you draw it here or over here, it will hit 4 times. So we call that concave. Okay, so this review that we're doing right now, I'm going to try to split into 2 days. So we're going to try to spend about half the time today and then half the time tomorrow. Okay, let me know if you have any questions. These are still a continuation of those last problems, concave or convex. Again, we're looking for where it could hit more than twice. Right now, we see right here, it hits 4 times. This has to be concave. But over here, no matter where I draw it, it's never going to hit more than twice. So this has to be convex. Okay, find the measure of one exterior angle of each polygon. So this is the exterior angles. You have to make sure you're reading this carefully because they're all asking for different things. So for exterior angle, we want to find the sum of the interior first. We got to count how many sides we have. 1, 2, 3, 4, 5, 6, 7, 8. So we'll find the sum of the interior. That's 8 minus 2, because remember that form is n minus 2 times 180, which gives me 6 times 180. Let me put that in my calculator. 6 times 180, 1,080 degrees. Okay, so that's the sum of the total interior. But we want to know the exterior angle. So let's say it was right here. Actually, I found a quicker way of doing this. There's no sense of me making you do it this long way if we can do this a little bit quicker. So I apologize. That's still good information, but let's see if a quicker way would be just to create these straight angles here. So these exterior angles we're seeing. So we see that this forms 8 exterior angles, which makes sense. It's irregular because it told us there. So we're able to do the sum of all the exterior angles has to be 360. And we know that there's 8 of them. So to solve for that, we just divide by 8. So instead of doing all that other work, we can just do 360 divided by 8, which would give you the exterior angle of 45 degrees. Same over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So again, 11 exterior angles. We do 360 equals 11n. Well, 360 divided by 11. It's going to be about 32.7 degrees for each exterior angle. Now this one says find the measure of one interior angle of each polygon. So interior angles are back to that original formula that I started with. It's going to be that n minus 2 times 180. That one looks pretty pathetic. I'll rewrite it, 180. So we got to figure out how many sides we have. 1, 2, 3, 4, 5, 6. So 6 minus 2 times 180 gives me 4 times 180. 4 times 180 is 720 degrees. So that's the total sum of the interior. But we need to make sure if we're finding of one interior angle, well, this means that we have the same amount of interior angles as we do sides. 1, 2, 3, 4, 5, 6. So you're going to take that 720 and you're going to divide it by 6. So 720 divided by 6 tells you that each individual angle will be 120 degrees. We're going to do the same thing over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we do 9 minus 2 times 180 gives me 7 times 180. 7 times 180 is 1,260. And then we had to spread that out between all the angles. So we'll just find 126 divided by 9, because that's the total angles on the inside. And divide that by 9, and that gives me 140 degrees. And the last one on this page says find the interior angle sum of each polygon. So this is just the interior angle sum. That's what we've been doing on these last examples. So we want to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we do that 12 minus 2 times 180. Give me 10 times 180. Remember when you're multiplying by 10, you just add a 0 to the end of whatever you have. So 1,800 shall be our answer here. Our next one, we're going to count how many sides we have here. 1, 2, 3, 4, 5, 6, 7. Again, I remind you, please pause it if you need to. So this is going to be 5 times 180. 5 times 180 gives you 900 for our interior angle sum. Okay, so now we are on to area. So remember, area of a square is side squared. So here, area equals 6 kilometers squared. So 6 times 6 is 36. It's area, so whatever your unit is, make sure you have it squared. Same thing here, area of a square. So it's going to be side squared, which leaves us with 9.3 inches quantity squared. I'm going to put that in my calculator. You can too. Sound a little sing-songy. I won't break up into too many songs in this because it's a little awkward to hear myself being recorded. 86.49 inches squared. Fun. Okay, and then this one's where we're going backwards again. So as we go backwards, we are able to have the area using the same formula. Area equals side squared. Here we don't officially know it's the square though, so I should actually write base times height. And here we want to put it in 127.7 kilometers squared equals base times my height of 11.3 kilometers. I get b by itself. I'm going to divide both sides by 11.3 kilometers. 11.3 kilometers. Okay, so on this side, you have the same thing in numerator and denominator. They go away. It's equivalent to 1. The other side, we have to 127.7. We're going to divide that by 11.3. And that does, in fact, give me 11.3 kilometers. So we do see this as a square, or pretty close to it. And we're going to do the same thing over here and verify that it's a square as well. So 90.3 feet squared equals base times height. So 90.3 feet squared equals, I probably could have done this instead of my first step, 9.5 feet times my height of h. Divide each side by 9.5 feet. Divide each side by 9.5 feet. So we have 90.3 divided by 9.5. And that does, in fact, give me another 9.5 feet. So make sure you're showing your work on those type problems. Just because it looks like it doesn't mean it has to be. It could be a little off. Now we're just at rectangles. Area equals base times height. So area is going to equal 8 inches times 9 inches. 8 times 9 is, I feel like I should get to call on you guys, 72 inches squared. And then over here, area equals 7.5 times 10.6 miles. So I'm going to do that one real quick. 7.5 times 10.6. That gives me 79.5 miles squared. And again, we're going backwards, so we have 65.8 yards squared equals base times my height of 9.4 yards. When I get base by itself, I'm going to divide each side by 9.4 yards. So 65.8 divided by 9.4 gives me 7. Double check my math there. But I will do it myself, I guess. 9.4. Okay, yep, 7 yards. Worked out pretty. Okay, over here, area again is 18.3 equals, let's put our units on there, Jenkins. Kilometers squared equals base of 3 kilometers times my height of h. We want to get h by itself, divided by that 3 kilometers. 3 kilometers. You see, as this happens, our h is now going to be 6.1 kilometers. Okay, let me know if you guys have any questions on this page. We only have one more page of this review. So this review for today and tomorrow is not going to cover any of the areas specifically, like of a trapezoid, a parallelogram, and we'll do circles. So I think those are the two we're missing, in a rhombus. That's the other one. So we're still going to have to review those in a different way. But right now we're just going to focus on angles now. So we want to figure out what the interior measure is here. So 1, 2, 3, 4. This is a quadrilateral, so we know how much that is. Instead of the 1, I know that can get confusing. I put an X there. So we know all these inside angles are going to add to 360. So 112 degrees plus X plus 125 degrees plus 90. Remember, that's what that little box stands for. We've got to combine some like terms. So 360 equals X. You guys do your math like I do mine while I do mine. So 112 plus 125 plus 90. I got 327. Okay, we want to get X by itself. Subtract over the 327. So 10 minus 7 is 3. That leaves me with a 5 here. 5 minus 2 is 3. So X is going to be 33 degrees. Over here, we got to figure out how much this is going to be. So 1, 2, 3, 4, 5. Sum of the interior, we got to calculate it now. So 5 minus 2 times 180. So 5 minus 2 times 180 is going to be 3 times 180, which is 540. Again, where the X is, I like to put, or the 1 is, I like to put an X. So we have 540 equals X plus 110 plus 105 plus 140 plus 90. Okay, we're going to combine those like terms. So 540 equals x. We're going to do 110 plus 105 plus 140 plus 90 equals 445 is what I got. Subtract over 445. So we have 540 minus 445, and that gives me 95 degrees. And last one of this style, we get to count the sides one more time. 1, 2, 3, 4, 5, 6. End up with 6 minus 2 times 180. That's 4 times 180. I got 720. Okay, again, where the 1 is, I put an x. So 720 equals x plus 144 plus 135 plus 114 plus 153 plus 106. Combine like terms, we get 270 equals x plus, 144 plus 135 plus 114 plus 153 plus 106, 652. Subtract over 652. We're going to subtract that from 720. It's going to be 68. And now we're on the exterior angles. Remember, where the exterior angles for all polygons is going to add up to 360. That was one of our theorems. So 360 equals x plus 77 plus 126 plus 102. Combine those like terms to get 360 equals x plus, so we have 77 plus 126 plus 102. That's 305. Subtract over 305. It's going to be 55 degrees. Okay, and then the last one here on this group, same idea. We're going to put an x in here. X, we'll do 360. So don't forget that one, equals x plus 65 plus 81 plus 48 plus 104. Okay, so we have to combine those like terms. 65 plus 8. 65 plus 81. That was a close one. Plus 48 plus 104. That gives me 298. So 360 equals x plus 298. Subtract over 298. So minus 360. That's going to be 62 equals x. So our angle that's missing is 62 degrees. And then the last one for this group is that parts of rectangles problem. So we're going to find the areas. So here I'm going to call this A1. It has all the pieces already listed for me. We see my width. We see my height. So A1 equals 4 inches times 15 inches. Okay, so 4 inches times 15 inches is going to give me 60 inches squared. Okay, then we go over here into this middle section, A2. This one's a little trickier. You see for A2 that this whole length was 14. And we know this top part here was 4, so we have to do 14 minus 4. 14 minus 4. And we also take off this 3, which will leave me with a distance of 7 up here for my length, because that's the part not accounted for. And then from the height was that 15, and we're going to subtract the 10 to get down to the height that we need. So 15 minus 10 gives you 5. So for area 2, we have 7 times 5. So 5 and 7 inches. We know that that multiplies together to give us 36 inches squared. And then from there, our last section, you know the A3 has a width of 3 inches. It's given right up here. But we were at 5 inches for this height, and then we're going up 7 more. So that's going to be 5 plus 7, which gives you 12. So 12 inches. So that's going to be 36 inches squared there as well. Oh, you guys, I know you can't correct me, but you should have. 7 times 5 is 35, despite how many times I put down 36. That was bad math on my part. I apologize. Okay, so then we're going to find the area total. Well, area total is 60 plus 35 plus 36. I'm going to throw that in my calculator real quick just to be safe. 60 plus 35 plus 36. You definitely hit the wrong button there. 60 plus 35 plus 36. 131 inches squared. Okay, so this is the end of the review for day 1. Again, this is not all-encompassing, but it does cover a lot of the section stuff from sections 8.1 through 8.3.